Hi, welcome back to our Honors Geometry series. In this video, we're going to talk about how to prove triangles are congruent. So the first thing we always do in our proofs is we get our givens down. And let me label all of the things that they said were congruent in the given statement. AB was congruent to CB. AD was congruent to CD. Angle ABD was congruent to CBD. And ADB was congruent to CDB. So these two were congruent as well. And kind of an interesting side note, you've got a straight angle, and those two adjacent angles are congruent, so x plus x equals 180. Then these both have to be 90. Not really important that we note that. As long as you note they're congruent, that's all that really matters. And I want to be able to show that these two triangles on the left and the right are congruent. So how am I going to do that? Well, I need to show that all corresponding sides are congruent and all corresponding angles are congruent. So what am I missing? I am missing side BD and angle BAD. I want to say that that angle here is congruent to BCD. So I need every angle and every side. I have two angles. The only angles I'm missing are these two. And I have two sides. The only side I'm missing is BD. So I'd really like to be able to say that these two angles are congruent. But how can I say that? They're not vertical, they're not a linear pair. I don't really know anything about these angles. But I can use a theorem that we just learned in class, the third angle theorem, that says that if I have two angles, or two pairs of angles rather, that are congruent, then the third angles in those triangles must also be congruent. And I've got those two pairs, so then I can say that angle BAD is congruent to angle BCD by the third angles theorem that says that if you have two pairs of angles, which we do, that are congruent in triangles, and that's only for triangles, then the third angles must be congruent. So I can use my third angle theorem to say now that these angles must be congruent. Then I'm only missing this side, BD. Let's see. BD, and what does BD correspond to? Well, BD corresponds to BD if you look at the congruence statement. So how in the world can I say that BD is congruent to BD? Or that something is congruent to itself? Well, if something is congruent to itself, hold on, that's the reflexive property. So I can use the reflexive property to say that those two things are congruent because it's congruent to itself. Then I've got BD, I've got my angles. That means that every single thing that's corresponding is congruent. Then I can finally say that ABD is congruent to CBD. And there are a lot of ways you could claim this. I would just say that all corresponding parts are congruent. You could also say that it's the definition of congruent polygons, also an option. Let's try another one. So I'm given all these markings already. And I would like to show that these triangles are congruent. So I've got two sides, I need a third side. I need to show that KL is congruent to LM. And I need to show that my two angles that are missing are also congruent. So I need to show that K and M are congruent and L is congruent to L. So I need angle JKL is congruent to angle PML, and angle JLK is congruent to angle PLM. So we can just copy down the givens. Okay. Usually we do our given statements first, and then I ask my students to find anything in that given statement they can define. Here, it's that word bisector. What does it mean to bisect KM? Well, it means to cut it into two equal parts. So if that KM is cut into two equal parts, then what are my two equal parts of that segment? That would be KL and LM. So KL is congruent to LM, and why can I say that again? Because that's the definition, that's what it means to bisect a segment. Okay, so that's done. Now I need JKL is congruent to PML. All right, I don't know if I can do that one yet. Let's try this last one, JLK. That's the one in the middle. How can I prove that these two angles are congruent? Well, I can show those are congruent because they're vertical angles. So I can say JLK is congruent to PLM because they're vertical angles. And vertical angles are congruent. So I've got that done. Then I need one more thing. I still got to say that J, KL, and PML are congruent. But what do I have? I have one pair of congruent angles. I have two pairs of congruent angles. I need a third pair of congruent angles. So if I have two, I need a third angle to be congruent. Then how can I say that JKL is congruent to PML? Well, that's the third angles theorem. That says that if I have two angles are congruent, or two pairs of angles that are congruent, rather, then the third pair is also congruent. And since I've got everything I needed, I can say that JLK is congruent to PLM. Again, you could go with definition of congruent triangles, or all corresponding parts are congruent, or something like that. Here's a third practice problem you can try. I will post that with my completed notes. That proof will be complete, and you can check your work there if you want to check this answer. Otherwise, send me an email or stop by in the mornings or after school briefly to ask any questions, and I will see